I'm repeating myself a little bit. But if I asked you to do this, you guys, I'm starting so slow. I'm just trying to make up an example that makes sense. If I asked you to use S of 6 to approximate this interval, and determine it. How accurate this approximation is. Let's go to the second part of the question. In order to determine how accurate this is, wouldn't I use that approximation formula? My goodness, we lost a lot of this over the break.
Depressed about
Wouldn't this happen? The error in using Simpson's rule with n subintervals is bounded above by nothing more than, gosh, does anybody remember how that was?
It's K
Times
B minus A
raised to the
fifth
all over
180
ties into the
fourth.
I agree. Where? I think this K thing out of thin air is nothing more than, in English, is nothing more than an upper bound for the absolute value of your fourth derivative function of value of x, at least over the interval. From, I made the numbers up, you guys out of thin air, 0 to 6.
Well, why at least? It isn't at 4?
I'm sorry, I missed that. I didn't catch it, Dave. What do you
Oh,
mean?
you said at least at the fourth derivative, so you can plug in the fifth derivative as well?
I don't know, maybe I didn't catch what I said. I'm saying K is an upper bound for the absolute value of the fourth derivative function, at least over this particular interval. I just meant over this interval, not beyond.
Okay.
When you say upper bound, do you mean the highest y value of the graph of that?
Okay, now be careful. I understand what you're saying. You're saying it's sort of like this K is the highest y value for the fourth derivative function. Not necessarily. What if your fourth derivative function did this? X-axis, y-axis. Now what would K be? I mean, if this really was what the graph of your fourth derivative function does over the interval from 0 to 6, I mean, if you can possibly read my horrible writing, what would your K be? Said that would be positive 8. I think K is an upper bound for the absolute value of your fourth derivative function. How about if I say differently? How about if I say this? Don't graph it. Instead, consider the graph of this beast. Isn't the graph of this beast right here, sorry, that's an absolute value bar, the same as the graph of what you see in black? It's just that whenever you have a portion of the black curve below the x-axis, reflected through the horizontal x-axis. Now the upper bound for the absolute value of the fourth derivative function is truly going to be the positive 8. Do you see my point? And you guys, what about this? What if this happened?
Why?
Why what?
Why is the opposite value? What's the logic?
Because when it comes to an error, even when I discuss the error using Simpson's rule, it doesn't matter if I deviate above or below the error by a certain amount. I just want to make sure I've got the greatest deviation from the true value, whether it's above or below. And I think that's what errors are all about. They, in a sense, don't even take into consideration whether you're above or below whatever your desired value is or what the actual value is.
So
I think that's irrelevant.
delta epsilon all over again?
Well, I hate to put it in those terms of delta epsilon, but it is certainly something you want to worry about. You guys, outside the math classroom, you would never realistically use any approximation technique unless you knew how far off you were with using that approximation technique. Approximations do you no good unless you know how accurate they are or how inaccurate they are. What if your fourth derivative function did this? Now, is k gonna be 8 or 2?
You would have to do the fifth derivative. to
Thank
find
you,
that.
I don't know what it is. Actually, in this picture, if this truly were the graph of the fourth derivative function, I think the k value is nothing more than the absolute value of the y-coordinate local min. So how to find the local min of, listen to my words, this function? I differentiate this function, but differentiating this function gives me the fifth derivative function for the original f. Do you see my point? And in this example, I hope, when I made this up in my head just now, that's what's gonna happen. Let's check it. Since this is my nifty little formula for generating an upper bound for using Simpson's rule, then let me take out a piece of scratch paper. Let me try to find what my k value is. And my original function f was x plus 6 times e to the negative x. So here's the first derivative function. Second derivative. Third derivative. You guys see where I'm going with this. And finally, the fourth derivative. So my question is this, over the interval from 0 to 6, is it clear that this function is monotonic? Is it clear, just obvious to you that it's strictly increasing or strictly decreasing?
No.
See, I don't think it's clear at all, Bradley. Do you see my point? And since it's unclear, I think what I should do is take the fifth derivative and see what the heck happens. And taking the fifth derivative, I get an x plus 1 times e to the negative x. Where? I think my fifth derivative function, if I can write it, is equal to 0 simply 1.
So, if you look at that, and it looks like it's decreasing, right?
If it's obvious that it's decreasing.
So, wouldn't you just be able to state that it is decreasing at that point? Because,
Yeah.
I mean, it's pretty obvious it's decreasing, right?
Dysfunction?
As you take derivatives of it, it's x plus 6, x plus 5, x plus 4. So the values are getting lower.
But is it decreasing pictorially as well? I don't think.
I don't know. Yeah, I mean, I couldn't picture this.
Can I say this
Yeah.
much? Bradley, check this out. I think of my fourth derivative function look like this. And I'm looking at this interval right here. You know, y equals 25 or x is 6 is clearly a decreasing function. I think everything's obvious. I think in this example, and now that what I've done with the fifth derivative function, maybe it is strictly decreasing. Can you guys allow me? If I don't make you upset, would you allow me to do this? So that now there's an issue.
What did you just do? Oh,
I
okay,
changed,
okay,
sorry,
negative
that's
6, yeah.
0 to negative 6. So that, I think now it's an issue. I think from over the interval from 0 to negative, from negative 6 to 6, I've got a critical number. What the heck does it mean? Well, it means my absolute max for the absolute value of the fourth derivative function might occur at this critical number, but also might occur at the
Endpoints.
endpoint. So let's do this. Let's check our fourth derivative function. E value at the left endpoint. Yes.
How do you know it's your absolute max versus absolute min?
Because I'm looking at absolute values. I just want to get the biggest one.
Okay, so just, okay.
Let's take the fourth derivative function evaluated at the critical number. Let's take the fourth derivative function evaluated at the right endpoint, and let's look at their absolute values. And somebody told me in class last time, Wednesday or Tuesday? Tuesday in class, somebody told me that I plugged these three numbers back in the original function. I don't want to plug in the original function. I want to plug in the fourth derivative function because that's what I'm trying to optimize. Do you guys agree? In this example, do you guys mind if I finish? It shouldn't be that bad. Fourth derivative function there, when x is negative 6, when x is negative 1, when x is positive 6, without pulling out my calculator, I think I can answer the question. I think the absolute max for the absolute value ends up being that. At least over the interval from negative 6 to 6. So Bradley's still not a great example. I was
Yeah.
trying to make one up to where the critical number actually yielded the most.
Oh, I see what you mean,
optimal
yeah.
value. And I apologize if the author doesn't dive in this, but you have to agree with me. You have to agree with me. Pure magic, if every single exercise in the book has a fourth derivative function which is strictly monotonic. Don't you agree?
Yeah.
I'm glad you agree. Yes, sir.
I'm confused about absolute error when that comes into play. So on the quiz, I evaluated my integral and used that as C.
Oh, to see how far off your approximation was.
Right. Yeah, so I
Was-
used that as my error instead of...
Was that what you wanted us to do? Because when I saw exact value, I figured there's only one way of getting the exact value, because you're getting an approximate doing it that way.
I wonder if anybody printed the quiz. David, you probably did, right?
I did, I have
Green paper and print.
The green paper?
yeah. Okay.
Aha. Ooh, now wait a minute. Listen to the choice of words. And please attack me at my choice of words. I really might be unclear.
Okay.
It is number one, correct?
Number 2.
Number 2.
Oh. Yes, I want you to divide the integral.
Okay.
That's what I intended.
Cool.
So, but
Question number one, listen to my choice of words. Use S of 4 to approximate this interval. Give both a completely simplified exact value and an approximation. I want an exact value for that approximation. Get the idea?
and
You had to combine them all.
An approximate exact value?
No, I was saying this way. Give the exact value of S of 4.
Okay.
And then number 2 is, because I was a little bit confused whether to evaluate the integral number 1 or number 2. I read the number 1 as you said it, but number 2, I evaluated the integral, but I don't recall the exact wording there.
How accurate is the value found in number 1 to the actual value of the above definite integral, meaning evaluate the definite integral by hand? Which isn't bad, is it? It's probably one step
No,
with
it's not.
integration by Parsons.
Yeah.
Actually, I used U subs on that one.
Oh, did you?
Yeah, and I got 2 as my answer. I did 2 U subs. I'm not really sure how because the other
It's the same
answer,
value.
well, yeah, the other answer, if you do by parts, integration by parts, you get something that's very close to what the actual value was from number 1.
Really? Okay.
But if you do U subs, you get 2. So I'm not. I could show you my U subs because
Yes,
I didn't.
U
I didn't
sub.
actually put that one on the test. But,
We've already killed it anyway. Did you guys like my quiz
That's
number?
me.
Did you generate that?
Very free. 17.
So do you guys recognize this function?
The floor.
Is that the floor function?
Yeah, the floor function, the greatest integer function. So the greatest integer less than or equal to negative pi is
3. Or,
Negative 4.
So let's just quiz 9. And if that's the integral, then Brad, let's do it your way. You said use a U sub, so what did you let U be?
I let U be, I believe, the natural log of x squared plus 1.
Then here's your du.
Well, what I did is I did e to the u equals x squared
okay,
plus.
gotcha. So you went ahead and said e to the u is equal to x squared plus 1, so e to the u minus 1 is equal to x squared. Did you keep going?
Yeah, actually, I took the root and then I took the derivative of that on.
So now you said this integral.
Oh,
right here.
wait.
Yes,
No.
I'll wait.
If you took the square root, how did you get 2x?
Oh, sorry. I didn't.
Okay. And so I took the derivative of that, which is like
My
1
goodness.
over 2.
okay, I was going to say,
Yep.
how does that work?
I'm not trying to do too much in my head.
Okay.
And then I did
So-
U subs with that too.
That's where you stop and apply your substitution. So you're saying this is equal to another integral. I'll slow down now. I guess another name for the natural log of all the stuff I just proclaimed was a u is just that your dx ends up being this mess.
Wouldn't that be 2 underneath it?
Oh, did I miss a 2?
Yeah, because
You're right.
it should be 1
There
over 2.
is.
Yeah.
I agree. My goodness, does that really help though?
What was your second use of? Or
Oh, I might have got a U in the denominator as well somehow. That's probably where I
Now
screwed
that
up.
would have been nice. If you
Yeah,
got a
that,
U
that would have been
downstairs,
nice.
that
Yeah,
would've
but
been
that's where I screwed up. But it worked out so perfectly like that.
I'm sorry. I'm sorry. Anybody else? How's the homework coming? Yes, sir.
So what phrasing would I be looking for, like which error technique to use for the absolute versus that complex formula and still different?
wait, there's an absolute versus complex.
Well, there was only one, and the only one involves finding an upper bound for the absolute value of the fourth derivative function. So that's the only one you have. So there are no choices.
Well, when do we use this absolute value of c minus x absolute?
So like on the quiz.
Because
Right, on the quiz.
in the book, on the last questions, using the trapezoidal rule, on the homework, they were using tables, and I wasn't sure what was going on, because
You know what, you guys? I'm sorry. I don't know what's going on either. Can I look?
yeah.
I apologize. I really, off the top of my head, can't imagine what you're referring to.
And on 31 and 33, they had, n was equal to like, I think it was like 50 on one of them and like 25 on the other.
It was just getting ridiculous.
And
In 25?
yeah, and I
Oh,
think there was one
see.
where it was equal to 100, and
So
I might be a little rusty on
You
these,
gotta
but
say this.
yeah.
He's got some nifty little formulas that say, if you're gonna use Simpson's rule on twice some value of n, you could interpret this as 4 times the trapezoidal rule evaluating the same thing, minus the trapezoid rule evaluating only on n.
Wait, why?
This is what he's using as a formula. He's got another one. I think it's trapezoid with 2n subdivisions. I think is this. I never used this. I don't remember. I'll have to look. I think.
Oh, it's because that's the one that number 15 I was asking you about.
But am I wrong?
No, that's
So do you have to actually do these trapezoidal rules by like writing out 25 different?
Well, that's the beauty behind what he's doing, at
Equations?
least with this one, is that if you're gonna subdivide your intervals into 20,
Yeah.
you can do it by hand. I can see the point of using this formula, because now you're using these two rules, but only using 10 subdivisions.
Okay.
I mean, it can help in that fashion.
But is there a shortcut to that?
Not in terms of using the trapezoid rule with 10 subdivisions.
well, what's the
Okay.
point of that when you can just take the limit of the Riemann sum within the actual?
Well, I certainly wouldn't go as far as using a limit of a Riemann sum, because that means you're avoiding integration techniques. Sorry, you're avoiding, approximation techniques.
But if you're doing 50 or 100, I mean, that's just ridiculous.
All right, I see your
Yeah.
point. Would you want to use Riemann sum, the limit of Riemann sum, to evaluate this interval?
Probably not.
Yeah, probably not, because I have no technique for doing that. I can't evaluate that limit. I can't even evaluate this integral in closed form unless A and B are the same.
Should you really just write that out like 100 times, or
Well, I
like
program my calculator on the computer to do it for me, or use a built-in program for that.
how would you do that on a scientific calculator?
Sorry.
Set
No,
aside
okay.
12 hours.
But there are many cases, Dave, where I just want to use an approximation technique. And so I don't have a choice. I can't go back to the limit of the Riemann sum.
I guess the only reason I'm asking is if you have a ridiculous amount of intervals that you're trying to evaluate. I mean, using something like that, I understand would help, but there's only so much paper we can use and only so
Yeah.
much time we have.
Even half of 100 is 50.
So in an exam situation, you guys, when you come in for the exam, I'll be doing much like I did here in the quiz. I'll have you use S sub 4, S sub 6, nothing outrageous, but just show me that you know the technique.
Could you maybe shoot us some problems, you know, later on today or something like that? Just post them online.
I'll be happy
That
to.
would be better
Go into
than
the
the
homework
book.
section.
Okay.
I'll put a few more in there.
Okay.
In fact, as of today, my life becomes so much easier. I'll be honest with you guys. I don't go to my office to do this. I have to stay in the classroom. My computer's so bad. But it's being turned into a doorstop today, so things are going better. Sir, I didn't notice this you're referring to. You're saying the difference between this and this.
No, and the, E is less than or equal to the one we were just working on, the
Now-
longer one.
That's the one I need you to worry about. I need you to know this, to be able to use this formula. That this is bounded above by k times b minus a equal to all over that 180 times n to the fourth. I do need you to be able to use this formula. I just don't expect you to remember it. So in an exam or an in-class quiz situation, I would somehow give it to you, whether it's on the exam or I slap it on the front of the board. Now, I may not tell you where to use it, but I'll certainly give you the formula. And you know when to use it by a question like this.
So what does the E actually stand for there?
Error.
Error? Okay.
And using the Simpsons rule within subdivisions. So, sir, here are the two questions I'd ask. You just used S sub 6 to approximate some interval. How far is that off the actual value without computing the value of that definite interval? Then you use this formula. I could ask you a backwards question, though. I can ask, give this definite interval with your bounds of integration given. How many subdivisions would I need to guarantee me this kind of accuracy? I still think you're using the same formula. Or you're just solving for n.
Right.
The second question. Those are the kinds of questions I can ask you. Now, I know your author goes into using that adjective relative in front of the word error. But that comes into play with this. I've got a balloon with a volume of 10 cubic meters. But I just blew it up, and it increased by a half a cubic meter. So I think the balloon increased by a half a cubic meter. But what is the relative change in the volume? I think it's that half of a cubic meter divided by what the original volume was, which is 10 cubic meters. And so somewhere in the book, he does divide out by x and calls that a relative error instead of the actual error. And that's what he's referring to. I don't care about that. That's fine. I assume you know that stuff anyways. So I wouldn't ask you that kind of question. I'm sorry, sir, do you have a question? Is it Tyler?
Oh, yes, for this formula, does it matter if it's less than or equal to?
Oh,
Because I think it's like this in the book and another way somewhere else. Also, the formula is different, but that could just be given.
you know what, you're right. I think he writes it this way. Hold it. I think he says, I meant equals, by the way. I think he writes it this way. You guys watch me. Using your math D skills. Is that okay? Wait, no math D yet. Sorry, no math D. Now math D.
Why would he write it like that?
I'm just asking, can I?
Huh?
Yes.
You can, yes.
But the reason why some people would like to write it this way is when you take a peek at this piece right here, what's really being raised to the fourth power is just your change in x.
Yeah.
And I think that's the way the author writes it. Maybe finagles it and writes it as a single fraction. But it means the same thing, doesn't it? That's what I'm saying.
Yeah.
Using my math skills, you're all with them. They're equal to each other.
Well, why would you do that? I mean,
Um,
what would be the point?
I don't like it for this reason. You see B minus A interpreted two completely different ways. Why bother? I just don't think it's necessary. Besides, now if you want to find out how many subdivisions you need, keepers, gotta go back to something like that.
Where he does use just a less than and not equal to is for k. So fourth derivative is less than k,
Oh, is it really?
which makes it sound like k is not on the graph of the fourth derivative.
Oh, yeah, and you know what, when I did it myself, I always came up with that one value. I could have chosen anything bigger, doesn't make any difference. I mean, if I had found this to be the case, here's the x-axis, here's the y-axis, you guys hold on a second. So my fourth derivative function, graphically speaking, looks like that. And I'm trying to find that k value, which is an upper bound for the absolute value of the fourth derivative function over the integral from, how about 1 to 3? Can I choose k to be in my picture? Can I choose k to be equal to positive a?
Yeah.
Yeah, I think that's an upper bound for the absolute value of, my fourth derivative function. Could I have chosen k to be 9.3?
No.
See, I think I can. I think 9.3 is at least as big as the absolute value of the fourth derivative function.
But outside your bounds though.
Well, I'm still looking at values for x here. I think for value of x between 1 and 3, 9.3 is an upper bound for the absolute value of the fourth derivative function. I could have chosen something bigger.
But won't that change your error?
No, it just means your error is no bigger than that quantity.
Yeah.
So how do you choose that if it's within, I mean, well, with that logic, you can go with 10,000.
Yeah, I know. I agree. In the end, isn't that going to make this number even larger? Which means that's going to be, your error is going to be less than that larger number, which makes complete sense. It's just not a very useful number, is it? Because I want to see how tight my error might be. And I just think it's so big. It's sort of like saying, what's my age? You don't know it. Well, most of us don't know it. But if I say, give me an approximation for my age, and don't be off my age by more than 100 years, wouldn't you say, well, he's 50 years old, or how about 20 years old? Because it's going to be off by more than 100 years, who cares? It's not a very tight restriction. I see. And I think it's a useless range.
Can you, in the book, they talk about lowercase k and capital K. Are you?
Do they?
I think they use lowercase k
For the upper bound of the fourth derivative function?
for maybe the trapezoidal rule, or the error for the trapezoid rule.
Well, I'm sorry, you guys. I keep having to do this. I don't know if his language or notation is different. I haven't noticed. Oh, sir, you're thinking of a subscript. Check this out. I want a yes or no answer. Is that okay? Is that correct?
Is that an I?
It is
yeah,
an I,
yeah.
yes,
Okay.
Yep.
What about this? Is that the same thing?
Yeah.
So what you're saying to me is that when it comes to an index variable, who the heck cares what you call it? And so if you're going to think of the trapezoidal rule with n subdivisions as being a computation, which is nothing more than delta x over 2 times f eval x sub
0. 2. X of 1. 2.
down to the last 2.
And minus 1. F of x.
Now, if you think of this right here as delta x over 2 times, I don't know, some function involving subscripts, you can call the subscripts whatever you want. K's, i's, makes no difference. So when he used lowercase k, he was using it as a subscript. That's all. Why? Because it's common notation. In mathematics, whenever we use index notation, we try to stick to letters like I, J, and K, not that it's important.
And so for the Simpsons rule, the capital K is also a subscript.
This is not a subscript because it's written at the same level as everything else. When I use the word subscript, I mean, some kind of lowercase indication that there's an index variable ranging over some subset of financial numbers. Let me put it this way. In this particular formula, I don't think I'm doing a good job answering your question. What's K?
Fourth
It works.
derivative integer.
An upper bound for
The fourth derivative.
the absolute value of the fourth derivative function, evaluated x, over whatever the heck of the integral is, which involves your bounds of integration. Now, personally, when I write this, I typically use an uppercase K, but I don't care, this could be either. But that's not the same thing as a subscript. Like, for example, the error in using Simpson's rule with K subdivisions, I think that K is different than that K. Because this is being used as a subscript for S, it really refers to how many subdivisions I have of the integral from A to B in using Simpson's rule. So these K's are definitely not the same.
Oh, so I mistook your S as a G, and on the quiz I put E of G of N. So when you be able to do that quiz, it's
I'll figure that out.
E of
Don't
G
worry.
of N.
I'll figure it out. Oh, you guys, you gave me 15 minutes. Can I introduce what I want to discuss next? It'll just be an introduction. Actually,